Alright, so now in this video we're going to take a look at this circuit. What this is I have, right now you can see the green LED is on, and the board's kind of losing connections and stuff, so we'll see how it does, but it's doing just fine now. We're getting a little flickering, but in any case, we should get a solid on-off for these two LEDs normally. But in any case, what we have is these two LEDs are wired backwards from each other. This is the output there, and so current flows through one in one direction and flows through the other in the other direction, and they light up when current's flowing through them. So we can create an alternating current with these two transistors, which are wired as in the push-pull configuration. So now zooming in, this is a PNP transistor. And so I haven't drawn out schematics yet. I'll do that in a later video. I have for transistors though. But in any case, the flat side is facing us, 2N3906, a PNP type transistor. So the emitter is there, the base there, and the collector is there. Flat side is facing us. The NPN transistor has the same pin layout, but as you can see, we turned it, we like swiveled it this direction. So the emitter, if you think of a swivel, in the same spot, but now we got the base there and the collector up there. Positive supply powers the NPN transistor at the collector directly to the collector in this circuit. The PNP transistor is connected directly to ground, so we get 2 voltage points here, 5 volts there because we're using a 5 volt power supply, 0 volts there, and other end of the load you can see we have a voltage divider, so 0 volts there, 5 volts there, but they both come to the same point. Since they're equal value resistors, 220 ohms in this case, we will have 2.5 volts at that point. So ultimately that's the difference, either 5 volts to 2.5 volts or 0 volts to 2.5 volts. And now we'll look at the base. So I got this little jumper there connecting the two bases on the other side of the base here, or on the other side of the transistors I should say. I'll take the power supply off, that'll make it easier to see. But other side of the power supply, you can see we get our signal from the switch, and these resistor values don't really matter. This keeps the current coming in positive, the voltage at least coming in positive, and to the base of that transistor. Both bases are connected though, and this transistor turns on when the base is more positive than the emitter. This transistor turns on when the base is more negative than the emitter. That's why there's only one transistor that's on or off at the same time, because they have the same signal coming in, but they both react differently to that signal. So the switch, as you can see, there's a resistor there from the positive rail to that one, giving us the positive voltage and current. When you think of current, positive and negative. When we close the switch, you can see we're connected directly to ground. So any current flowing through this resistor will go directly to ground. So the transistors don't see that. They just see that this resistor is now connected to ground, 0 volts, and that's when the PNP transistor turns on. So now the value of the resistors, these are 220 ohm resistors. Since we're using a 5 volt power supply, 220 ohms resistor and LED provide about the minimum amount of current you want to use. This circuit kind of makes it a little more confusing, but you can see we have the positive rail, 220 ohms, negative rail, 220 ohms. Since they're equal value resistors, we'll get half of the voltage difference between the two rails. Now these are 1 kilo ohm resistors. Their values are the least important in this circuit because we're getting a voltage to the base of the transistors, and that's what sets the voltage coming out of the emitter of the transistors. They get their power from this rail. So all you're doing is setting the voltage with these resistors. It's going to be either the positive rail or the negative rail, so either 5 or 0 volts. So you can differ these resistors by a huge value. I don't know when it's going to finally get too high. But in any case, you'll get the voltage of the pins. Remember though, the base to emitter is a diode, so you lose about 0.6 volts in the process. So if we give 5 volts, we're actually going to have about 4.4 volts. If we ground it, we're actually going to have about 0.6 volts at that transistor. And so now with those voltage differences, you got to remember that the LEDs are dropping about 1.8 volts each. These particular LEDs at low current, they're going to drop about 1.6, 1.8 volts. As you pass more current through them, they block more voltage. But we're not getting much current because we have 2.5 volts on one side and either 4.4 or 0.6 in that range. Either of those two voltages come into the other side, and then they're dropping 1.8 volts. So they're dropping practically all of the voltage difference. And so we're not really getting any current in this circuit. But this circuit was just a demonstration to show that we can alternate current with this configuration, even though we have a DC power supply. That only provides direct current. Let's turn this lamp down so we can see the LEDs a little bit better. That's how little current is flowing through. So very little. So this is not a practical circuit. But there you can see that the LEDs are passing current in different direction. Again, I need to stop using this board. It's an old board. And but in any case, the green LED is set with the long lead up here, short lead where the two resistors connect, so that when the output here is more positive, it will light up. Whereas the red LED, the long lead, is where the resistors are. So that one conducts when this side is more positive and that side is more negative.